Thank you, Mo, for the introduction. Maybe you will see me dance tonight after some beers. Now I will show you a dance between performances and Android TV. So yes, I'm Maël from BAM. I'm currently developing a React Native application on TV at TF1. It's a French TV channel, one of the most popular. So today I will discuss about the memory management issues we faced at TF1 and what was our journey debugging memory. But first, let me explain why we are using React Native at TF1. So most TVs like Samsung, LG, Sony, and most box like Apple TVs, Google TVs, Fire Stick are connected and capable of launching applications like your phones. Most of these devices run on Android TV, which is a version of Android for TV. Other run on web, and Apple TVs run on tvOS. It's like iOS, but for TV. So like many of your applications, we use React Native to share code across all these platforms, and React Native Web to target web platforms. And so it allows us to, to deploy our application to almost 8 different stores and a lot of devices. But the problem is that performances of these devices are really inconsistent. Some devices are worse than Motorola, so maybe you should consider using your TV and not buy a Motorola. It's simpler. That's why we need to monitor these metrics. So let me tell you about the day we wanted to launch our app into production, but the memory consumption was skyrocketing. So, as I mentioned, we have a strong constraint. So, our memory consumption, the RAM, should stay below 200 megabytes on this specific device. And our app were using too much memory, so we couldn't deliver it to our users. That was a problem. So, we need to reproduce it. It's simple. First, we launch the app. So, welcome to TF1 Plus. Then we select a program. So it's Les Bracelets Rouges, a French program. And then you launch the player. So you look at the video. And last but not least, you do it 100 times. Quite easy. This makes sense because TV users never kill their application. Maybe you use your TV every day and never kill the application on it. So we want our app to be robust and not consume too much memory if users are looking at TV every day. So to automate the process, we created a script using ADB. So it allows us to reproduce the process easily and avoid taking time to do it 100 times manually. And with this, we can draw a graph. And yes, we have a problem. The memory is going up to 360 megabytes and the application crashes. That is not acceptable. So our first step is to, we want to debug it. So our first step is to formulate an hypothesis because it's a general debugging advice. You have to do an hypothesis, test it, find a way to test it easily, and then iterate. Maybe you find the problem and you correct it, you fix it. Maybe you do another hypothesis. So in our case, the memory is going up to 400 megabytes and the app crash. So we are not experts, not yet, but we can say, okay, memory is going too high. Maybe it's a memory leak because there is a memory issue. And when there is a memory issue, we say, oh, memory leak. But before diving into it, let's see what is a memory leak. But to understand what is a memory leak, there is another concept, which is garbage collector. So to understand how memory leaks occurs, we have to understand first what is a garbage collector. So we are on Android TV, so on Android, the garbage collector can vary depending on the operating system version, but they all generally follow the same principle. First, it identifies routes. It's called GC route. So it's the entry point of your app. Sometimes it can be activities, it can be static classes, but to have a simple example, let's say it's our application. Then this route have references to other objects in memory. Imagine you have two screens, home screen and player screen. Maybe you have it with a React Native screen. And this screen also reference other objects to run the application. And so all these objects are reachable objects because they are reachable from GC routes. Let's say we have a player. We can show it in the green here. So for now, our app consumes some memory, but it is necessary to run it. But what happens if the user leaves the player screen? The player screen will not be referenced anymore by the application. So it becomes a non-reachable object because we can't, it's not reachable from GC route. And all other objects referenced by a player screen become non-reachable. So when the memory is still used at this moment, but when the system is running low in memory, or when the garbage collector sees that there are a lot of non-reachable objects, the object can be removed from memory, so they explode. But what happened to our player? We had a reference from our application because maybe there is an architecture problem. We had this at TF1. Maybe there are an event listener in the application using the player. So yes, the player is still referenced, so it's still reachable, and the garbage collector can't clean it. So we have a memory, what we call a memory leak, because we are not using our player anymore, but the garbage collector can't remove it from memory, and this is a memory leak. Okay, so that's the theory, but in practice, whether my node is reachable or not, I don't care. I want to know where my code is leaking. So how can I find it? So maybe you can. I don't want to read heap dump like this. So I didn't introduce it, but the heap is a part of the memory where you can have your memory leaks. And you can dump the heap with Android Studio, but yes, it's quite hard to find. I don't see my code. I see bytes, I see float. So, okay, maybe I can see an increase of bytes, but I want to see what is leaking. So, do we have a tool to find it? Of course, yes. There is a tool named Leak Canary. So, it's an open source library created by Square. It's like the software mentioned, but for Android. So it's an open source library created by Square, and it reports memory leaks in your application and help to find them. It's widely used in the world of Android mobile development, but not necessarily known to all React Native developers. So we will see how it helped us at TF1. So first, it's easy to install. So here is a screen of the document, a screenshot of the documentation. You add the dependency, and that's all. It's no configuration needed. You can run it. So then you launch your app, you reproduce the problem, and yes, we see our first pop-up from Leak Canary. So if you see this pop-up, you probably have a memory leak. It's saying for retained objects, there is a leak. So let's look at logs. You can find it in logcat or in a special Leak Canary activity. And we see a stack trace. And in this stack trace, it's little, but we will zoom after. We see which object is leaking, and all the references to this object are underlined. So if we zoom at it, we can see that player activity is leaking. And it's retained by zzag.zzh. So yes, if you're lucky, the leak is in your code, so you find your code and you can debug it easily. But we are not lucky. It's a leak that occurs in an external dependency. So yes, it's hard to read. But it also say where is which dependency is leaking. And we see it's in Android, in the media library, in media manager instance. So it's kind of weird. Is Android code having a memory leak? It's Google, it's a big company, maybe they don't do memory leak. Ah, no, we found the issue on Google Issue Tracker, and it seems to be that one. So yes, to let you know, there are a lot of leaks in Android. Sometimes it can be more or less important. In our case, it was our player, so it's really important. So before thinking about fixing it, let's just remove the feature. Yes, we removed the feature literally. So yes, it worked. We measure the memory again, and it's good. The blue line is under the red line. And it will have yes, we couldn't go into production because of Google. So it would have been hard to find it without Leak Canary. Finally, Google released the new version with the fix, so we could update the dependency. So we are good. We can say memory leak are easy to find because we found leak canary. Memory debugging is really simple to do. There is no problem. No, it's not like this. It's one of the most challenging problems I have faced in my life. So, and we spend day of debugging memory. So you will see why. Let's talk about another time, like 2 weeks after. We wanted to update the application on the same store, so same device, same store. And people reviewing your app said, your app consumes too much memory. We are not going into production like this. Again, because we have leak canary, we don't have problem again. Just a small reminder, we want to stay under 200 megabytes of RAM. So we do the same thing as before. We reproduce the problem with our small script. And yes, the problem is back. Okay, so let's formulate an hypothesis again. It's the same process. We are expert in memory debugging. So the memory is going up again. It's a memory leak. No, it's not, because we have leak canary. It's not reporting anything. So it should not be a memory leak. And if we look closer to the graph, we see that the app is not crashing because when memory goes down, we look at our TV, nothing seems to happen. So why the memory is going down, but the app doesn't crash? So we said before that the memory leak is when the garbage collector cannot collect memory because we have references to objects in our code that are left. But here the memory can be collected. So maybe it's not a problem with the memory leak, it's a problem with the garbage collector. It's not, it doesn't run often enough, maybe. So it's our second hypothesis, that's the problem in the garbage collector. So first step, we look at logcat, so to see logs about our application, about the system, to see if we can find some log about the garbage collector. And yes, we find some logs, a lot of logs. It seems to run really often, and there are a lot of logs. So garbage collector runs, but it seems to collect nothing because memory still increase. So what's happening? We found a specific log occurring only when memory goes down, which is a memory warning called trim memory complete. So in Android documentation, we found that it's a log saying that the system is running low on memory. Okay, why not? And our app will be the next process to be terminated. Oh, it's a problem. So we saw that the app wasn't crashing. So how the memory is liberated if the app doesn't crash? Because if our process is terminated, the app crash. We searched a bit about this trim memory complete log, and we found something in React Native core repository. It is a function. So we listen to system memory pressure events like trim memory complete, and we respond to them. Or not we, React Native responds to them. And when a trim memory complete event occurs, it calls the garbage collector. So, oh, yes, there is something with the garbage collector, but we are on React Native side. We are not on Java or Kotlin side. So it's calling JavaScript garbage collector because when you do React Native, you have JavaScript side with Hermes running your JavaScript code. So it was a problem of with the garbage collector, but it was not the Android garbage collector. It is the Hermes garbage collector because there is not one garbage collector but two garbage collector. It's kinda complicated. But okay, let's look at it. Imagine you're creating a player. It's I work for TF1, so we have a lot of players. So on JavaScript side, it will create a player variable, okay? But maybe our player is Android code because we use the Android player. So it will reference a Java object, but maybe this player will also reference native object. So like images, animation, SVGs, and C++ allocation like string or other things. And your JavaScript code can also reference native objects. For example, when you do a fetch, there will be a native allocation, but your fetch is in JS. So let's put number into it. Maybe your JavaScript object is very small because it's just a variable with almost nothing in it. But your Java code is a little larger because it has more code. And the native object can be a lot larger because it might include images, SVGs, like I said before. So for the moment, we don't see why your app is consuming 400 megabytes of RAM. But what happens if we create 300 JavaScript players? Maybe for player it's kind of hard to understand, but like as I said before, it can be your fetch, it can be components, it can be a big state. So it can happen. So on JavaScript side, you only have 15 kilobytes of memory used. So Hermes only sees that, and it will not run the garbage collector. But on Java side, your objects are still referenced, so it has 300 kilobytes of code, but it's still referenced, so garbage collector doesn't run. And on the native side, objects are still referenced, so we can't remove them from memory. But if we look at our native objects, there are 150 megabytes of native objects. So yes, JavaScript is retaining up to 150 megabytes of native object because Hermes only sees 15 kilobytes of code. So in practice, how did we fix it? So we found an issue on the Hermes repository related to memory usage during API calls. So we could reproduce the problem with an empty app that made only API call. And there were two problems. One in Hermes related to fetch. This is linked to a leak in Wikmap. And a second problem that was the Hermes isn't aware of native memory usage. So the Hermes team addressed the first issue, the issue in Wikmap, and it should be included in React Native 74, so it's released today. And for the second issue, Hermes team added a method that allows native libraries to inform Hermes how much native memory a JavaScript object retains. So it's more useful. It's useful for native library maintainers. So Hermes can take it into account for garbage collection. On our side, we are not on React Native 74, so we just run the garbage collector in the background. It was a quick fix, short-term solution, and it works. So yes, we have this in production. It concludes our second example. So to conclude with all what I said with debugging memory, there is no easy way to debug it. Each time you debug something, it's a different thing. So there is no magical formula that lets you debug everything easily. But the main things that can help you in debugging memory are first, locate where the problem is, because we saw that it can be in JavaScript, in Java, or in native. So first, locate the problem, because we lost a lot of time by not locating the problem. Then you have to simplify your system because it can take time to reproduce problems. Like sometimes we run a script for 3 hours, so it's better if you can automate the process and reduce the lead time. And last but not least, please install Leak Canary. It doesn't cover anything, but it's a must-have for memory leaks in your Java or Kotlin code, and it's really easy to use. So thanks for watching. You can find me on Twitter or GitHub. For GitHub, it's an I and not an L. But thanks.
Awesome. Come along, Maël. Interesting choice of a GitHub handle. Purposefully misspelling your name is new. Okay, cool. Well, thank you for doing that talk. TV is near and dear to my heart, so it's cool to see that. And I would ask you to dance on the stage right now, but we'll leave that for later, I guess.
But if you have some alcohol, maybe I can do it. But
I don't. But other people might. I don't carry alcohol on myself, on my person. It's not encouraged. Cool. All right. So let's jump into it. And again, for the audience, you could just reach Slido there. Generally, your experience on TV apps, and I think we went specifically deep into the topic of memory leaks and memory usage. But I'd love to just hear what are the biggest gotchas? What has your experience been? Because I'm presuming you did mobile development before.
Yes.
So what was the biggest gotchas and the biggest challenges going from a mobile development perspective into TV development?
I think when I was developing for mobile, there was some issues on low-end Android devices, but yes, really performances on TV are sometimes horrible. So, for example, at TF1, we don't use flash list, flat list. We have a custom list to have good performances. So performances are a big issue. And also the navigation, because you have to use your remote and TV remote. So it's weird at the beginning when you see it for the first time.
Yeah, definitely. There's a lot of gotchas there.
But for the other side, it's like iOS or Android.
Yeah, very cool. Awesome. So let's jump into some of the audience questions. So firstly, there's a question on Leak Canary, and if there's an equivalent on the iOS side, or are you finding that on Apple TV there's generally just not that many memory leaks?
Yes, I haven't see from iOS because Apple TVs can take like 3 gigabytes of RAM, so we have. But it can be important. But I never debugged memory on the iOS side.
Yeah. So for context as well, Apple TVs are probably an outlier in the entire TV industry. Most devices will have 500 megabytes of RAM, and they cap you at certain amounts. Or if you go to setup boxes, it gets even worse. Apple TV basically stores the same chips that they use for phones onto the Apple TV devices, which is extraordinary. So it means stuff like this doesn't really apply as much, which is great. Because
so buy
less
an Apple
headache.
TV.
Yeah, just buy an Apple TV, I guess. Morgan has a comment, I guess, saying that the bug, I'm presuming the bug that's being referred to here is related to the Android bug with the memory leak, was opened in 2017, and the beta version fixing the issue was in November 2023?
Yes. Yes, because we debugged it like in end of November, and we were like, okay, so we have a leak for 3 years ago. The leak was here, and the fix is like 2 days ago.
Wow.
So
okay.
Yes.
Well,
We
love your
lucky.
maintainers, folks. It makes you really appreciate every single open source maintainer that we have in our community, right? How do you get metrics for memory usage from Android and the native side? What's the way to access that information?
Yes. Yes, I couldn't cover it in my talk, but with ADB you have a lot of tools, and with Android Studio too. On ADB there is a command that lets you see the native memory heap, the native heap, the Java heap, and also other memory, which is like a JavaScript heap. So you can find where is the problem, and then debug in Android Studio or Canary.
Someone asks, is Google solving these kinds of issues quickly? And the answer is absolutely not. It takes them 6 years to do it, apparently.
Yes, and on TV there are not a lot of users, so
how do you create a system in place, and how do you prevent these type of issues happening in the future long term? What is there a strategy that you
Ah,
have in mind and the teams put into place?
So now each time we install a library like React Native SVG, or when we want to go into production, we have a script, not the script I showed, but like the same type of script, and we run it every time to see, okay, we are at 150, it's good, or no, we are too high, we have to remove React Native SVG. We have removed that.
Okay, cool.
But yes.
Someone's asked me how I feel to be able to talk to someone about RN on TV, and the answer is eclectic. I feel absolutely great. Thank you for asking. Biggest challenges, we've covered them. So we've looked at some of the challenges on doing React Native on TV, and there's a question on, and I think you just touched on this, which was consistent measurement of memory across the board, even if it's not garbage collector related, but just tracking the memory. And there's systems in place, I'm presuming, that does that as well.
How to do it consistently?
Yeah, to consistently sort of measure the memory usage.
I think it's a big issue because, for example, for garbage collector, depending on how the box is, not depending on our application, just the box, the issue can be there and the issue cannot be there. So sometimes I touch the box and I'm like, oh, it's hot. So the garbage collector will run often. It will not work. So I had to restart the box and say, okay, no, the fresh restart, it's good.
Yeah. Okay. Sebastian Lorber has an interesting question, which is, what would you have done if Google hadn't fixed it?
Okay. So the real story is that this was an issue with an old library for Exo Player 2, and Google have launched a new APIs for the player, like Media 3, and so our player, it's not us that do the player, it's another team, migrated to the new libraries, and there is it's not the same dependency. So, but if we couldn't fix the leak, I don't know. Maybe just remove the feature. It was something with media session, so like for Google Cast or something like this. But yeah.
Cool. Question that's being asked is React Native adding a noticeable overhead when you compare to native development? I'd love to get your take on this, and I might chip in a little bit on this one as well.
I think what I learned at TF1 is that we can do it. So if there is an overhead, it's not a big overhead. And an other TV app, I will not quote them, but are consume much more memory and are native.
Yeah.
And I think the only things to know on React Native is that your bundle is in your RAM. So it's good to have a bundle analyzer, like
and the bundle is small in that sense.
So if the bundle is too
low. And to chip in on this, I think especially on TV development, actually the gotchas and the issues that arise are more around the overhead is more around the codes that the developers are writing, because we assume you can go in and use a regular list and that will behave as you expected and the performance will be fine. But in reality, that's not the case. And you can implement a really bad list on TVs in just native Kotlin as an example, or Swift is less of an issue, but in general with native Kotlin. And so it becomes a matter of creating hyper optimized components for TVs that are limited in the API functionality because TVs use remotes, but they are heavily performant. So that becomes the priority. Cool. Well, thank you so much for doing this talk. It was very interesting. And yeah, we'll see you around.
Yes, thank you.